this video, we are going to discuss the different types of tree traversals or binary tree traversals which exist. So, these traversals are of three types: one is in order, post order, and pre order. So, as you can see from this little illustration that I've drawn here, that in order, the root is in the middle or it is in the order, and then in post order the root is after the other traversals, which is post orders. Therefore it's post, right? And in pre order it is before the traversal. So the position or the traversal order of the root basically determines the order or the name of that particular traversal, right? So these are the three types of traversals that exist in tree traversal: in order, post order, and pre order. In the previous video, we have also explored how in order traversal for a binary search tree renders an ascending order of elements, right? So we will discuss how all of that is connected in this video. First of all, let's take an example tree. And let's start with 40, 20, 10, 30, 60, 50, and 70. Great. So now we have with us a binary search tree. So for this binary search tree, this is a very good example of a binary search tree. You can see that the left node for this is smaller than the root node, and then the right node is bigger than the root node, and this follows for every subtree of this binary search tree. Now for this binary search tree, we can traverse this in multiple ways, but there are three main ways that we can apply it. One is in order traversal, where we traverse the left root first, then the root node, and then we go to the right node. There's also post order, where we go to the left node first, then we go to the right node, and then we go to the root node. And there's also another kind of traversal, which is pre order, when we go to the root first, then we go to the left root, and then we go to the right node, right? So these are the three types of traversals that exist, and we will practice this and see how this works on this particular binary search tree after we understand the working of these algorithms, right? So first of all, let's take a general tree. A, B, C, D, E, F, and G. Great. So now we have with us the different nodes that we have. So let's first understand how in order for this tree will go. So let's refer to this particular order: left, root, and right. So this is something that is constant, and you have to remember all these orders, right? So these are basically the algorithmic workings of these particular traversals. So first we go through left, root, and right in order traversal, right? Left, root, and right. But if we check out the first left root that we need to, the first node that we need to check out, we see that it is not an empty node. It is not a lone or a leaf node. It also has a subtree attached to it. So we also have to traverse this subtree, and for that we will again apply the recursive method and go again to the leftmost, and then we will go to the root and then the right. And do we see any other um, subtrees attached to this leftmost node? No, we don't. So now we will mark this as our marked, right? So we will write D here. Let's choose a different color. Yeah. So D is the first element that we have marked, and the one thing that we need to remember about all these traversals is that we can't go and randomly access any elements. We don't have random access here. So we have to start with the root, and we have to start and check each of the elements and then reach the last element that we can, right? So we have reached D. So this is left. And now for this particular node, we have to go to the root element, which is B. Then we go to E. Why? Because left, root, right. Okay. Now that we are done with this subtree, we are done with left for this one, right? We are done for left of this root node as well. So now we are going to traverse the root node, which is A, and now we are going to move on to the right one. Now for this right subtree, we can see there is a left here, there's a root here, and there's a right here. So we are going to traverse it again in the similar pattern, which is F, C, G, right? So this makes us done with the in order traversal, in which we traverse it in this way: 1, 2, 3, and then we go 1, 2, 3, 4. Okay, so that's how we did the in order traversal for this particular tree. Now let's see how this works for this one. This is the binary search tree, right? And let's see how this works for here. So the in order traversal for this particular binary search tree would be left, root, right, left, left, root, right, left, root, right. Okay. So now let's start the in order traversal, which goes 10, 20, 30. And then we go here, which is 40. And then here left node 50, 60, and 70. So did you observe something? The in-order traversal renders an ascending order here. Yeah, we were right, and now we have already proved that the in-order traversal for a binary search tree gives us an ascending order of elements of that particular binary search tree. So now let's move on to our next sort of a traversal, which is known as our post-order traversal. We will draw a similar binary tree here, F and G. So for post order, let's refer to the sequence that we have defined here. Okay, post order, it is left, right, and root. So for post order, we have left, right, and root. So now let's start with the root node again, because this is our entry point for the entire search tree. And we have left, right, root. But for this left root, we have again another binary subtree which goes left, right, and root. Great. So now let's start writing the sequence for this. So for post order, we first of all, we did not land here, we landed here because this is the leftmost, right? So let's go and write D. Then we go to right, which is E, and then to the root, which is B. Great. So we are done with left root, right? And now let's see how this differs from in order traversal. This was DBE and this is DEB. Now let's come to our, this subtree is done. Now let's come to the right for this particular node, right? So this is this subtree, and then further when we traverse this subtree, we go to F, then we go to C, and then we go to G, and then we go to C, right? So left, right, and root. And for our last subtree is done. Now we can go back to our root. So left is done, right is done, and now we go to root. So this is the post order traversal for our binary subtree and for our binary tree. Now let's try this on our binary search tree as well. Post order is equal to, what was the algorithm for this? We go left, right, and root, which is 10, 30, 20, and then we go left, right, and root, which is 50, 70, and 60, and then we go 40. So this is the post order traversal for this binary search tree. Now let's learn the last algorithm that we have for today's video, which is our pre-order traversal. So our pre-order traversal will draw another binary search tree to understand this. D, E, F, G. Right. So for our pre-order traversal, let's have a look at the algorithm again. So this algorithm says we have to traverse in the order root, left, and right. So how do we go about root, left, and right? We are very well versed with it. So first of all, we start here. We go A. So the first thing that we write down here is A. And then we start traversing, and again it was root, left, and right. So now we have landed upon our left subtree. So left subtree, and in this subtree we have B as the root, left, and right. Now let's write down what we have next. So root, left, right, right. So and in this particular subtree, root, left, and right. So B, D, E, root, left, and right. So we are done with this subtree. Now we are going to move to our right subtree, which is again a subtree with root, left, and right. So here we are going to traverse again in the same order, root, left, and right. So this becomes C, F, G. So this is the pre-order traversal for our entire tree, which goes root, left, root, left, right, and then we again go right and root, left, and right. Great. So now we are done with our post-order traversal here as well. Let's write down the order for our convenience. Root, left, and right. And now let's have a look at the example again. Let's solve that for this particular binary search tree. So pre-order traversal here would be root, left, right. So 40, 20, 10, 30, root, root, left, right. And then we go to our right subtree, which is 60, 50, and 70. So this is our entire traversal of binary trees and an example of a binary search tree as well. We have been able to understand how in-order traversal works, post-order traversal works, and pre-order traversal works. In-order traversal works in a way which follows the order left, root, right, and post-order traversal follows the order left, right, and root, and pre-order traversal follows the root of root, left, and right. I hope you were able to understand all the types of traversals that we have with us in the tree data structure and how we can traverse through a binary tree and a binary search tree. Thank you so much for watching. Like, share, and subscribe.